Okay, so when I taught you 2 weeks ago, if I gave you the position data, how would you calculate the velocity? Very good. So we're going to do it 2 ways. I taught you how to do it in 2 different ways. One is the discrete way and the other is the continuous way. The discrete way is we have velocity is nothing but change in position divided by change in time. All right, so we'll take 2 points. Let's say we take 2 successive positions from 8,9 to 8,8. If you take the difference between those two, and if you take the difference between 0.36 and 0.24, and if you divide one by the other, you would get the velocity. And I also taught you another way to do it using the curve fitting tool. Do you remember that, CF tool? All right, so let's do it the discrete way where we will take the difference. So what we are going to do is we are going to write a very small set of very small code to execute this. And this is how we're going to do this. All right, so let's go back to MATLAB. Okay, and we will write a comment line there. We will call it velocity. Okay. And how many times do we have to do this difference? How many rows of data do we have? Not the first 2 are junk, right? So we have 22 rows of data, and we can subtract 1 from 2, 2 from 3, etc. So we need a for loop. We need to do this thing. We have 22 rows of data, so we need to have a for loop that executes 21 times. So we will create a for loop. We will say for I equals 1 to 21. Okay? And we will say velocity of I, okay, equals so what I'm doing here is calculating the difference in the position. So when I equals 1, it's going to calculate y2 minus y1. That's the numerator, right? Velocity is change in position divided by change in time. So the numerator is change in position, and the denominator would be ti plus 1 minus tfi. Okay, so the numerator is the difference in position, and the denominator is the difference in time. Okay, so let's run this and see what this looks like. Okay, so the first one is 0.5, 0.50, and 0.5. So let's go look at our Excel file to see if that information is correct. All right, so 0.88 minus 0.89 is 0.01, and 0.34 minus 0.36 is 0.02. 0.01 minus 0.02 is 0.05. So our answer is correct. Okay.
Could you pull up the equation again, please?
Certainly. Okay, now we have to plot this quantity on the y-axis. And what are we going to plot on the x-axis? time. So what time do I use? Do I use the same time, or do I find out what time? So there's between two position data, there's a velocity data. So if I'm plotting position here as a function of time, if I have two positions here, I take the difference in the y-coordinate, and I'll take the difference in the x-coordinate, and I'll get the slope, and I'm going to get a value. And I'm going to plot that at a value of time that's in between these two times. So I have to calculate a new variable to plot the velocity. And let's say I call that time interval, INTV for interval. All right, I'm going to create this new variable called time interval of I, which is nothing but time at I plus time at I plus 1 minus time at I divided by 2. So it looks complicated, but what I'm doing is this. If I'm plotting this velocity, I need this value of time. If I'm plotting this velocity, I need this value of time. And how do I calculate that time? Well, it's the difference between these two times divided by 2, right? And that will give you just this distance. To that you add this distance. So time of I plus 1/2 this time. That's what that line is doing. Okay? So let's call this figure 2. And we will plot TINTV, comma, V. All right, and we will plot this as circles. So what I'm doing here is, let me move this up that way you guys can see from behind. Okay, I'm plotting the time interval, the new variable on the x-axis, versus velocity on the y-axis. And I'm going to, those data points are going to be represented by little circles. Okay, so each point there corresponds to the difference between the two y-coordinates divided by the difference between the two x-coordinates.
No, I'm not in trouble. I'm still getting the red screen down.
Okay?
Is it parentheses after vowel?
I feel like I'm missing something.
A comma after the V.
Oh, yeah. Oh, okay. And
Oh, no, it's figure 2, plot that. Figure parentheses 2.
so, parentheses 2, close it.
Yep.
Okay.
Next line.
Next. Oh, after
Just
this.
hit enter. Plot.
Alright, thanks.
Okay? So that is your velocity as a function of time. Okay? Now, how would you do acceleration as a function of time? You would take the difference in the velocity and divide it by time. Okay? So you have two velocity data points here, and that is in the variable v. Okay? So we will create another variable called a, where we will take the difference between the two v values. Any questions on velocity? Okay. If you're having a hard time understanding this, the best way to do it is run the for loop on a sheet of paper for just 2 or 3 values of I. Write the whole code down. pretend you're the processor and go through the for loops, do it 2 or 3 times, and then you will understand. Okay? Instead of writing the whole thing all over again, I'm going to copy all of this. And I'm going to paste it. And I'm going to change a few things. I'm going to call velocity as, I'm going to change velocity to acceleration. And velocity was the difference in position. Acceleration is going to be the difference in velocity. And create a new time variable.
Acceleration, your rate of change, should that be over the t interval?
Say that one more time.
Back to your acceleration.
Yeah.
Your a variable, you have it divided by the change of just t. Shouldn't it be the change in your velocity graph? So the change in your t interval.
Yeah, that's the t interval velocity. I'm taking the difference between 2 velocity data points.
So to calculate your a, right
Yeah,
there, that should be
yeah.
the t.
Thank you.
Good job.
Good spot. Thank you.
Is v or is it just the original t int?
There is no t int, right? It's t
You
int.
have it just set as t and v?
Yeah.
Yeah, alright.
Give me 1 second. Okay, so it can't go all the way till 21. It has to go only up to 20 because we have 1 less data point. Okay? All right. All right, so that's your final code there. Yeah.